All right, we are scheduled to do this at 11 a.m. on the dot, and according to all of my clocks on my laptop, my phone, my watch, etc., says 11 a.m. So let's get this done. Morning, everybody. For those who are just now coming in, my name is Ian Boatman. I'm a meteorologist at the National Weather Service in Wilmington, North Carolina, or as the cool kids call it, ILM, the initials of our airport where we're located. And going to have a great webinar today about learning about winter weather in the Carolinas, how we get there. You wonder how we get snow in Wilmington, and we're going to answer some questions about that. The next question is, can anybody see my screen? You're going to see a lovely picture of myself, my girlfriend, and the mascot of the University of Georgia. How about them dogs? Let's see if everybody can see my screen there. I'm going to switch over to a PowerPoint presentation here.
Yep, we see it.
Excellent, thank you. That was Steve Path, by the way, who is the morning coordination meteorologist for our office. One heck of a meteorologist and an even better human being, I'll tell you that. All right, folks, so we'll go ahead and get this show on the road. You know, we have things a little flip-flopped here. Let me put this here.
There you go, you got it.
Excellent, good. Thank you very much, Steve. All right, sorry about that, folks. I'm working with two screens here. So my laptop is what you see here in front of me where I'm looking at here, but I have my presentation over to a monitor here to my left. So there's a little bit of back and forth going on. So winter weather in the Carolinas. There's no way we can make that happen, right? Just no way. Actually, there is a way we can get there. Will we see it this winter? I don't know, we'll see. Hasn't looked good so far as we went through the month of December and into beginning of January in the new year, but we'll see what happens. So we'll go ahead and get the show on the road. We're going to talk about the averages and the normals of what we experience around here. Temperature, rainfall, snowfall. Of course, snow is the big thing that everybody will think about. Winter weather, climate patterns. There are certain things that we look for on the grander scale. Everybody's probably heard of about El Nino and La Nina. Those are the most popular ones that gets covered in the news a lot. But there's some other things that we also look at, and we'll talk about that a little bit later. We'll go down memory lane and talk about some old snowstorms. Way back in 1989, it was a white Christmas for those people that lived around here. And way back in 1973, that's one that my dad talks about a lot personally. We'll talk about those and how those played a role and how that can kind of give us an idea of future winter storms to look for, because weather patterns seem to have a similarity with each other. So we can kind of look to the past to give us an idea of what to look for. And then finally, we'll end with an outlook for this winter, what we've seen so far in the month of December and what we could see throughout the rest of January and into February. So meteorologists break down seasons in 3-month spans. And of course, in this 3-month span, we're in winter, which is specifically December, January, and February. Throughout this 3-month time frame, our normal highs and lows, temperature speaking, typically have highs in the 50s and lows in the 30s. Well, it looks like today we have temperatures that look more like that, but obviously in the month of December, we had a lot of high temperatures that were nearing record highs, if not broken those highs. Plenty of highs in the mid to upper 70s. We kissed 80 a couple of times in certain places. I think Wilmington hit that a couple times. So we definitely have been warm so far. Of course, on the other side of the spectrum, you can also have your record lows. If we do hit record lows around here, typically it's around the teens and the single digits. We have hit zero a couple of times, but that's certainly a much more rarer thing in the record low temperature realm, if you will. So that's kind of an idea of where we are temperature-wise. We'll go to the other side of the equation and look at the precipitation. Most of the time, that's in the form of rain, but sometimes you can have some other stuff show up. Snow, ice, things like that. We're still sticking in the same winter time frame from December, January, and February. Throughout that entire 3-month frame, we typically have around 9 to 11 inches. If you break that down in terms of the months, in a single month, you typically have around 3 to 4 inches a month. So that winter rainfall has ranged from about 2.99 inches going way back to the late 1800s to a very active winter in 1997 and 1998 with 23.34 inches. If you're in the weather world, you would actually know that's kind of a famous El Nino year. El Nino plays a role in this presentation. We'll get to that a little bit later. So far this winter, if you want to play the comparison game, depending on where you're at, in Wilmington or in the South Carolina PD region around Florence, it varies a little bit from about 2.5 to 3 inches of rain that we've seen so far this season. So we're running a little bit of a deficit. We're running a little low right now. Some of you might know that we're in a little bit of a drought right now. So staying dry so far on the drier side for winter's not the best idea. Although we did get a little bit of help a couple nights ago. We got a good bit of rain here. From what I was able to see, we got around ½ an inch to an inch in certain spots, with a couple of local higher amounts. So that has helped us out a little bit, but we need a little bit more help. We're still running a deficit. We got to get there. Hopefully we will. We'll see. Winter. Everybody's thinking about snow. Everybody's thinking about ice. So this is the main idea that we look for here. The average annual snowfall totals across the whole country. You have a color-coded map. I have that little yellow circle zooming in on us. In those teal colors, it represents 0.1 to 3 inches. That is the average annual snowfall totals in our neck of the woods. Well, that's a pretty big span there. And the reason is that because we have a large infrequency of these storms. They don't happen very often. And sometimes you get a lot, sometimes you don't get very much at all. The last winter weather event that we had was February 2020, where we had just a teeny dusting of snow in parts of Robeson and Bladen County, North Carolina. Some of you might remember the snow of 2018, in which we had a few inches around these neck of the woods. So you have variations there. Obviously, you have less snow at the coast, and as you get a little more inland, kind of kicks up a little bit. Back to the South Carolina PD region, you might have 1 to 2 inches thereabout in terms of the average annual. But of course, if you've spent any time around here or down south in general, you know that snow is not an every year thing. But if we are to get snow this winter, we're starting to enter into that sweet spot that might get us a little bit of luck. Of course, I say luck if you are a fan of snow like me. I know there are plenty of folks that hate it, so I don't want to offend you in that manner, but I must say I'm a snow lover myself. If you're looking for snow in November or December, not really going to happen as much. Have a little bit bigger window of an opportunity in December, but still not what you exactly want if you're a snow lover. January and February is known to be the sweet spot. So now we're getting into that time frame. Will we get that this season? That remains to be seen. Again, fingers crossed or not, depending on your viewpoint there. There still is a little bit of a shot also in March, but your chances really start to taper off as you get into spring. This is taking a look at all snowfall events in Wilmington specifically over a 150-year time span from 1870 through 2021, and we've had 118 measurable snowstorms in that time frame. So we'll take a look at the bigger picture here. We've talked about the Carolinas. Let's zoom way out and talk about global patterns. If you want a fancy term to this, we call these atmospheric teleconnections. It's a really fancy phrase, but all that means is basically one weather pattern that takes place on one corner of the globe dramatically can affect the weather on a different corner of the globe. There are these major global connections that are thousands and thousands of miles apart, but they really have an impact on each other. The biggest example that you guys probably have heard of in the past is El Nino and La Nina. So El Nino, you have these images here. The top image shows you El Nino. So what does that mean? You focus on the central Pacific ocean water temperatures just off the western coast of South America, near the equator. The colors on this map show you how far above or below normal those ocean temperatures are. If you're in an El Nino event, represented in the top image above with those yellow, orange, and red colors, that shows you that those ocean temperatures are above normal. They're warmer than what they should be, right? So that is the warm portion of the spectrum, and we call that El Nino. If you go to the bottom image, you have the other side of the spectrum. You have exactly the opposite, where all those blues represent that those ocean waters are colder than what they're expected to be. and that is called La Nina. Okay. Now again, this is the Pacific Ocean, way out there, right? That's a West Coast problem, right? We're East Coast, we're Atlantic. That's not a problem for us, right? Sorry, friends, it actually is a big deal for us. So El Nino, again, on the top left image there, this shows you your sea surface temperature anomaly, right? How far things are above or below normal. You have that little red line there, what that little black arrow is pointing towards. This shows you above normal Pacific water temperatures. How does that affect where we are in the southeastern United States? Go to the image at the top right. This shows you how temperature and precipitation wise things are affected all over the globe. So in El Nino, it might be a little bit hard for you to see there, but you have this little blue circle that's over the southern United States, representing cooler than normal conditions. Take a look at the bottom left image. You have the subtropical jet stream originating from the Pacific. Remember, Pacific is warmer in that area. That's bringing all that warm, moist air up through the United States. That air will cool down as it travels, but still keeps that moisture with it. So El Nino winters in the southeastern United States, the Carolinas included, is typically cloudy, cool, and wet. It's not always a guarantee, right? You could still have warmer than normal winters in an El Nino season, but this is an indication of what you could expect, right? That this is a way things could go if you have an El Nino winter. Flip that to the other side of the spectrum. Let's go to La Nina. Remember, Central Pacific Ocean, near the equator, west coast of South America. These purple and blue colors represented in the top left image. That shows you below normal temperatures in the Pacific. Why does that matter for us? Go to the image at the top right. You see in this yellow color that's outlined in the southern United States that you have drier and warmer than normal conditions for that particular area of the country. Of course, including the Carolinas. Reduced Pacific moisture that's not being surged in this area. You're dry, you're warm, and that's a La Nina winter. Now, that might sound kind of familiar, wouldn't it? Warmer than normal, drier than normal. That kind of sounds like something that we just had in December. So does that mean that we are dealing with a La Nina winter right now? Hey, look at that. La Nina winter is the current situation. The top image comes from the Climate Prediction Center. This is all part of the National Weather Service network. This was published in November 11th, 2021. So what, about a month and a half ago? About a month and a half ago, before winter even officially kicked off. The synopsis circled in blue, you may or may not be able to read it, so I'll read it aloud. La Nina is likely to continue through the Northern Hemisphere winter 2021-2022 at a 90% chance. Moving forward into spring 22, it's still looking like we'll have a La Nina at that point in March and May, but it dropped down to a 50% chance. But this presentation is focused on winter, so we'll leave the spring stuff for now. But hey, La Nina winter. Well, again, that would make sense according to what we just talked about. Warmer than normal conditions possible in the Carolinas. Yep, check. Looks like we've seen that so far. So it looks like La Nina is absolutely living up to its reputation. But for whatever reason, I mentioned this weird term called an atmospheric teleconnections a little bit earlier. I don't really even quite frankly understand why El Nino and La Nina are just the popular kids in the block, the ones that get talked about the most. Because as it turns out, we have a ton of atmospheric teleconnections to look at. I wrote papers about this in graduate school that made my mind spin. It was pretty wild. One of the things that I wrote about in grad school was the North Atlantic Oscillation, the NAO. The problem with this one, this is a bit trickier to predict. Go back to the previous slide where we talked about that we're currently in La Nina. Remember the Climate Prediction Center, they talked about this La Nina way back in early to mid-November, right? Again, before winter even really got its start. The North Atlantic Oscillation, that's only predictable 1 to 2 weeks in advance. It's really fast. You kind of have to be careful with this one. But the interesting thing about the NAO is that it can overwhelm every other climate pattern in play. If you have a really strong positive or negative NAO, you can forget about El Nino or La Nina, because that'll be the dominating factor, that NAO. So the NAO, the North Atlantic Oscillation, let's say it's on the positive side. What does that mean? You got yourself a really strong center of low pressure over Iceland, way up there. Again, corner of the globe that's way different from where we are. Why does that matter? Another corner of the globe, you got a strong center of high pressure over the Azores. These climate patterns play a role in keeping that northern jet stream pretty rigid. So basically, it just starts rotating on the northern portion of the globe. It doesn't really move anywhere. It stays pretty rigid. It doesn't do this wavy up and down kind of stuff. And that's a really important factor, because that keeps a strong polar vortex at the poles. Just this dome of cold air that stays way up there. Doesn't really travel down a whole lot. The cold stays locked up there with Santa Claus in the North Pole. So as a result, the Carolinas stay warm. So you might be thinking, well, have we had a positive phase of the NAO lately? Yep, we sure have. Funny how that works. Maybe you want snow this winter. What you would want is the other side of the spectrum, the negative phase of the NAO. What does that look like? You still got your low pressure in Iceland, but it's a lot weaker. You still got your high pressure in the Azores, but it's also a lot weaker. So that weakens the polar vortex. Things get very shaky. That upper jet stream, that stays in a straight line before with the positive NAO. Now it's all over the place. It's really starting to move. Yeah, that jet stream surge down south, really bring in that cold air into the picture for our neck of the woods. So you have these really cold blasts that come into the United States, Europe, and even Russia too. So that makes the Carolinas cold. You want snow, you want cold temperatures, then you want a negative phase of the NAO. Here's what the power of the NAO does in a negative phase. The coldest morning for the Southeast. Let's go back to January 21st, 1985. This was a really exaggerated case of a negative phase of the NAO. Let's check it out. Let's go to the mountains. Let's go to Grandfather Mountain, North Carolina. They woke up to a balmy temperature of negative 32 degrees. My goodness, can you imagine? You got any friends over at Appalachian State University at Boone, North Carolina? They woke up to a temperature of negative 24 degrees. Let's come back a little closer to home. Let's go to our friends in Morehead City, North Carolina, near the Outer Banks. They woke up to a temperature of 1 degree. I grew up as a kid going to vacation in South Carolina low country, so let's go there. Beaufort, South Carolina, they woke up to a temperature of 5 degrees that morning. Florence, South Carolina, big old fat 0 degree Fahrenheit they woke up to that morning. Ice cold, 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 all because of the negative phase of the NAO. Now, this is an exaggerated case. Not every, in fact, not most negative phases of the NAO would get you this cold, but a good cold blast is what you would get in general from the negative phase of the NAO. Now, we've talked about these big picture stuff, right? We zoomed out. Now it's time to zoom back in, okay? If we have a snow event to take place at some point this winter, what do you look for? What do you want to see on a weather map? So we're going to talk about that. So what you want, let's say you had a really good cold front that came through 3, 4, 5 days ago. You want that cold, dry Arctic air to just sit there. I mean, you want it really cold. You want it cold throughout the entire column, not just at the surface, but way up above your head, okay? You want that icy cold column all the way down. Remember, the atmosphere is 3-dimensional. You have to think about it like a fluid, like a bottle, basically. Because what is happening at the bottom of the bottle might be different from what's at the top of the bottle. You want consistency throughout the whole thing. You also want your ground temperatures to be cold, right? You want that snow to stick. Cold ground temperatures and soil temperatures, etc. Meanwhile, you got yourself a surface low pressure that's starting to form in the Gulf of Mexico. This is about a day before the event is supposed to happen, snow in our neck of the woods. It's low pressure that forms along a stationary front, a stalled front in central Florida. Notice I said central Florida, not North Florida, not South Florida, central Florida. That plays a big role. That low pressure reaches the central Florida Gulf Coast. These Carolina surface winds, they have to be from the north. Okay, this is a big deal. Not the northeast, because the northeast will bring in some air from the Atlantic. Probably still cool air, but not that really cold air that you need for snow. You want that to come from land, from the north. Okay, that's a really sensitive thing, and that's the big difference between ice versus snow versus rain, etc. That can make or break your day, depending on your philosophy. This low pressure moves through central Florida. Offshore, we actually have a specific, this is crazy to me, we have a specific location that we want this low pressure to be low at. The low pressure near 30 degrees north latitude and 75 degrees west longitude. That's exactly where you want it to be if you want the perfect snowfall scenario. If you want to get fancy, we got a little fancy earlier talking about atmospheric teleconnections. Let's get fancy again and talk about the Miller A storm track. This is exactly the scenario that you want. A single area of low pressure originating from the Gulf of Mexico, moving across central Florida and off towards the Atlantic coast. If you want snow in the southeast, this is exactly what you want. I was born and raised in Augusta, Georgia. I'm a Southern boy through and through. As a meteorologist growing up, wanting to be a meteorologist, this is exactly the snow that I was wishing for. Watching that low pressure in the Gulf and watching where it went, that was all that mattered. And it matters around here in the Carolinas just as it does back home in Georgia. You also have the Miller B storm track. This is good for snow for other folks in the country, but maybe not so much for us. You have low pressure that forms and moves across the southern Appalachians. This is good for your friends that live in parts of Tennessee, Kentucky, West Virginia, the mountains of North Carolina. That's good for those folks if they want snow. You know what we're going to get? More than likely, cold rain. Temperatures probably in the mid 40s. Cold rain, miserable. You stay at home and you watch movies and read a book under some blankets. This one can get kind of dangerous because you might be a little bit up on a line where you might get some ice into play. More than likely, it's a cold rain, but depending on that position of that low, you could get into some trouble there. So the Miller B storm track, that one is a little tricky. You want Miller A if you want just a straight up good snow event. So if you're a fan of snow like me, you keep your fingers crossed for a Miller A storm track as we get in further into the winter season. What does a Miller A storm track provide you? February 1973. My dad was also born and raised in Augusta, Georgia. He talks about this 1973 storm all the time. He was a teenager when this happened. In my hometown in Augusta, 14 inches of snow. How about that? Let's go to the Midlands and the PD region of South Carolina. 15 to 20 inches of snow. I cannot wrap my head around that, to be honest with you. Let's head on back to Wilmington. Anywhere between 10 to 12 inches of snow that day, or those few days. My goodness gracious. And that was a Miller A snow track that gave us that particular storm. It was the largest snowstorm in history for much of South Carolina. Let's watch this again. Let's fast forward a few years. Let's go to 1989. Probably the only time that this area has seen a white Christmas. December 22nd from 24th, 1989. A Miller A storm track provided 15 inches and more of snow in Wilmington. Parts of Brunswick and Columbus County, North Carolina, received 20 inches. That's the magic of a Miller A storm track. It's amazing. That also provided us the coldest temperatures in Wilmington's history. That Christmas snowstorm in 1989, 0 degrees Fahrenheit in Wilmington during that storm. That also happened during the negative phase of the NAO. That's what you want if you're a fan of snow. Now, we've talked about the past. Let's talk about the present. So where we're at going into this winter, where we've been, these images come to you from the Climate Prediction Center. You have the temperature outlook on the left, the precipitation outlook on the right. Going to the temperature outlook, looks like we're going to be well above normal for winter. Keep in mind, these images were published on November 18th, 2021. Again, about a month and a half ago. before you even get into winter. Has that verified so far? Yeah, pretty much. We're really warm for winter, and we've stayed on the dry side. Had a little bit of rain to make up for that a couple nights ago, but we still need more. We're still running a deficit. We need more rain. So that winter outlook, even though it was published in mid-November before winter started, we're still making up for it, and this forecast is coming out to be pretty good. That's La Nina. We'll see what happens from there. Some other factors that are in play, you have this double dip La Nina scenario because it's affecting both your temperature and your precipitation. And that's the pattern that we've seen. We've been in a La Nina period for a little while now, actually. There's some indication in this graph here that it might be swaying a little bit more towards the El Nino side. I am kind of curious to see what happens, let's say July or August of 2022. We might get more towards an El Nino or even a neutral phase. I don't know. We'll see what happens from there. But that's kind of an interesting thing to keep an eye on for beyond. Trends, climate change. It's absolutely a factor. You have things like the La Nina that are playing the biggest factor at this very moment in time for this winter, but climate change is still playing a little bit of a role in the background of it. We are warming, and that is not helping the trends of winter, right? You want cold temperatures in winter, climate change is starting to take that away over time. It can be exaggerated more in certain areas, but that's the pattern that we've seen from the 1890s through today. Seasonal climate models. So outside of other indices, we take a look at computer models to kind of give us an idea of what could happen in the future. So this is all sorts of climate models that we use to give us an idea. And all this stuff was taken away back in October and November to give us an idea of what things will look like over the next 1, 2, or 3 months. And all of them had an idea of, yep, looks like the southern United States is going to be pretty warm for winter. So all of these indices kind of came together to show us exactly what we're seeing now. So all of that is verified, which I guess is good news for us as meteorologists because we certainly want to be right. Well, looks like we nailed it. Here's the other side of the equation with precipitation. The previous slide was temperature, and this shows us our precipitation. These yellows and oranges and browns, it all represents us staying on the drier side of the spectrum, which absolutely also has verified. So once again, we are verifying that. So that's the presentation. That's all I got. Hope you've learned a thing or two about what it takes to get snow in the Carolinas and how we get there and the big picture and the small picture stuff to look at. I will take